This is SpaceTime, Series 20, Episode 30. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, SoundCloud, YouTube, Audio Boom, direct from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime is also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world through TuneIn Radio, and as in-flight entertainment aboard Virgin Australia. Coming up on SpaceTime, new clues for life on the Saturnian moon Enceladus, 4 new objects being investigated in the search for Planet 9, and a new study of the strange Casimir effect on nanoparticles. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Molecular hydrogen has been discovered in plumes erupting from Saturn's ice moon Enceladus. A report in the journal Science claims the hydrogen's part of a soup of water and minerals analogous to the hydrothermal vents at mid-ocean ridges on Earth, which are known to support life on the seafloor. The findings are based on a close flyby of Enceladus undertaken by NASA's Cassini spacecraft on October 28, 2015, as the probe passed through a plume of gas and ice grains spewing from cracks on the Enceladian surface. From these observations, scientists were able to determine that at least 98% of the gas in these plumes is water. A further 1% is hydrogen, with the remainder being a mixture of other molecules including carbon dioxide, methane and ammonia. Previous Cassini findings have suggested that hot water is interacting with rock on the seafloor. The new findings support that conclusion and add that the rock appears to be reacting chemically to produce the hydrogen. The study's lead author, Dr. Hunter Waite from the Southwest Research Institute in San Antonio, Texas, says an analysis of all the data indicates the hydrogen's best explained by chemical reactions between the moon's rocky core and its warm subsurface ocean. Hydrogen's a source of chemical energy for microbes living in the Earth's oceans near hydrothermal vents, and the new results from Cassini's ion neutral mass spectrometer indicates the same chemical energy source is present in the subsurface oceans of Enceladus. According to Waite, while the findings aren't evidence for the presence of microbial life in the oceans of Enceladus, the discovery of hydrogen gas and the evidence for ongoing hydrothermal activity offers a tantalizing suggestion that habitable conditions could exist beneath the moon's icy crust. On Earth's ocean floor, hydrothermal vents emit hot mineral-laden fluids, allowing microbial life to convert the chemically rich soup into metabolic energy, resulting in the creation of unique ecosystems teeming with unusual creatures. The presence of ample hydrogen in Enceladus's oceans means that microbes, if any exist there, could use it to obtain energy by combining the hydrogen with carbon dioxide dissolved in the water. This chemical reaction, known as methanogenesis because it produces methane as a byproduct, is at the very root of the tree of life here on Earth, and could even have been crucial in the origin of life on our planet. Life as we know it requires 3 primary ingredients: liquid water, a source of energy for metabolism, and the right chemical ingredients. Primarily carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur. With this finding, Cassini has shown that Enceladus, a small icy moon over 1 billion kilometres further from the Sun than the Earth, has nearly all of the ingredients necessary for habitability. However, while Cassini has not yet shown if phosphorus and sulfur are present in the Enceladian ocean, scientists do suspect them to be there. That's because the tiny moon's rocky core is thought to be chemically similar to meteorites that are known to contain these 2 elements. Confirmation that the chemical energy for life exists within the oceans of a small moon of Saturn is an important milestone in humanity's search for habitable worlds beyond Earth. In fact, the amount of molecular hydrogen detected by Cassini is high enough to support microbes similar to those that live near hydrothermal vents on Earth. If similar organisms are present in Enceladus, they could very well be burning the hydrogen to obtain energy for chemosynthesis, which could conceivably serve as a foundation for a much larger ecosystem. Previous Cassini flybys have already provided good evidence for a global subsurface liquid water ocean sandwiched between a crust of frozen ice sheets and a rocky core. The search for hydrogen specifically native to Enceladus, Cassini flew especially close to the surface, operating its ion-neutral mass spectrometer in a mode specifically designed to exclude potential background sources of hydrogen, thereby allowing scientists to quantify exactly how much molecular hydrogen is truly originating from Enceladus itself. Scientists also considered other sources of hydrogen from the Moon, such as a pre-existing reservoir either in the ice shell or in the global ocean. An analysis determined it was unlikely that the observed hydrogen was acquired during the formation of Enceladus or from other processes either on the Moon's surface or interior. Waite says everything indicates that this hydrogen does originate from the Moon's rocky core. The authors considered various ways in which hydrogen could leach from the rock. They found the most plausible source is ongoing hydrothermal vent reactions of rock containing reduced minerals and organic materials. Meanwhile, new observations by NASA's Hubble Space Telescope have detected fresh plumes of water also erupting from Jupiter's ice moon Europa. The new findings, reported in the Astrophysical Journal Letters, are based on Hubble observations of Europa from 2016, in which a probable plume of material was seen erupting from the Moon's surface at the same location where Hubble saw evidence of a plume back in 2014. Thomas Subrekin from NASA's Science Mission Directorate says the observations represent the closest scientists have come so far to identifying the place with some of the ingredients needed for a habitable environment. The new images bolster evidence that Europa's plumes could be a real phenomenon, flaring up intermittently in the same region on the Moon's surface. The newly imaged plume rises some 100 kilometres above Europa's surface, twice the height of the one observed back in 2014. Both correspond to the location of an unusually warm region that contains features that appear to be cracks in the Moon's icy crust, seen in the late 1990s by NASA's Galileo spacecraft. Like Enceladus, this could be evidence of water erupting from Europa's global subsurface liquid water ocean, which incidentally contains more water than all the oceans on Earth. The plumes on Enceladus are associated with hotter regions. So after Hubble imaged the new plume on Europa, scientists looked at that location on the Galileo thermal map. They found that Europa's plume candidate is sitting right on a thermal anomaly. If the plumes and the warm spot are linked, it could mean the water being vented from beneath the Moon's icy crust is warming the surrounding surface. Another idea is that water ejected from the plume is falling onto the surface as a fine mist, changing the structure of the surface grains and allowing them to retain heat longer than the surrounding landscape. For both the 2014 and 2016 observations, the team used Hubble's Space Telescope imaging spectrograph to spot the plumes in ultraviolet light. As Europa passes in front of Jupiter, any atmospheric features around the edge of the Moon block out some of Jupiter's light, thereby allowing Hubble to see the features in silhouette. The Enceladus and Europa plume findings are laying the groundwork for NASA's Europa Clipper mission, which is slated for launch in the early 2020s. Hubble's identification of a site which appears to have persistent intermittent plume activity provides a tempting target for the Europa mission to investigate with its suite of science instruments. This is SpaceTime. I'm Stuart Gary. A few weeks ago on SpaceTime, we reported on a new citizen science project being run by the Australian National University. The ANU project recruits members of the public to help scientists find evidence for a possible ninth planet in the dark outer reaches of the solar system. We can now report that astronomers are investigating a number of objects identified so far as part of the citizen scientist project. These include both numerous celestial bodies spotted within the solar system and a new system of 4 exoplanets discovered light years away. The newly detected exoplanetary system is orbiting a nearby star. All 4 planets are orbiting their host star closer than Mercury's orbit around the Sun. Of course, that means these small terrestrial worlds are far too hot to support life as we know it. But the discovery is important because the exoplanets' close-in orbits may help astronomers better understand the process of planetary formation. The Search for Planet 9 project was part of the BBC stargazing live broadcast from the Siding Spring Observatory in outback New South Wales. The BBC program had over 16 million viewers, and so far 60,000 members of the public have gone online to help in the planet hunting search. Volunteers are looking at hundreds of thousands of images taken by the ANU SkyMapper telescope at Siding Spring. SkyMapper is systematically taking 36 images of each part of the southern sky, which is relatively unexplored. Volunteers then compare images of the same area taken at different times in order to identify any changes which have occurred. It's something people still do better than computers. Combined, the volunteers have now classified over 4 million celestial objects. And that's allowed researchers to rule out a planet the size of Neptune being in about 90% of the southern sky, out to a depth of about 350 times the distance between the Earth and the Sun. Back in 2006, following the discovery of several bodies out beyond Neptune which are similar in size to Pluto, the International Astronomical Union voted on a new definition of planets, which demoted Pluto from its position as the solar system's 9th planet into a new category of dwarf planets. The first tantalizing evidence for a new 9th planet came in 2014 when astronomers identified several trans-Neptunian objects in unusual orbits. Trans-Neptunian objects are small frozen worlds, comets and other icy debris orbiting the Sun beyond Neptune. These include the Pluto-Charon binary system and their 5 moons, as well as all the other Kuiper Belt objects and celestial bodies further out in the more distant Oort cloud. The objects observed in 2014 were most likely placed in their unusual orbits through some sort of gravitational interactions with a large Neptune-sized planet between 8 and 10 times the mass and at least 2 to 4 times the diameter of the Earth. This hypothetical planet 9 would have a highly elliptical orbit around the Sun with an orbital period of around 15,000 Earth years. Its elongated orbit would bring it to within 200 astronomical units of the Sun during its closest approach, known as perihelion, and as far out as 1200 astronomical units during aphelion, its most distant orbital position from the Sun. An astronomical unit is about 150 million kilometres, or 8 light minutes, the average distance between the Earth and the Sun. If Planet 9 really does exist, then during perihelion it should be in the general direction of the southerly areas of the constellation Serpis and Libra, while it would be in the general direction of the constellation Taurus during aphelion. The ANU's Dr. Brad Tucker, who's leading the search, says the volunteers have already successfully identified the minor planets Chiron and Comacea, which demonstrates the approach being taken could find Planet 9 if it's there. The work being done by citizen scientists as part of the project has already allowed astronomers to achieve some 4 years' worth of scientific analysis in under 3 days. Tucker says SkyMapper is crucial for ruling out those areas of the southern sky where Planet 9 could be situated, and that allows the team to narrow down the places where it could be located. Tucker says his team are now focusing on the many newly identified objects to confirm whether or not any of them could be Planet 9, or alternatively, whether they're newly detected or already known dwarf planets or asteroids.
Stargazing Live turned out great. So it was a program that we ran with the BBC. In fact, there were 16.1 million people who turned in on the BBC week. So over 3 hours, it's actually a lot of people in the UK tuning in. And we found lots of great objects, both on the Planet 9 search and the exoplanet search that we ran across these programs.
What was the process involved in looking for them?
So for the Planet 9 search, we had hundreds of thousands of images to scour, and people were looking for a colored dot, so essentially spot the difference. And what people were able to do is by having multiple people check each image, tell us when there was something interesting we should follow up. And people have found thousands of things. We found Pluto, the dwarf planets Chiron and Charon. But we also found a number of unknown objects. So citizen scientists with their keen eyes said there's a few objects here that we don't know. And when we looked at databases, no one has seen these before either. So what that tells us is these require more follow-up, as in we're trying to figure out where they are now, so we may figure out what they are in their nature. Are they asteroids? Are they dwarf planets? Or maybe are they even Planet 9?
That's pretty exciting, isn't it? That's got to have you just about shaking with anticipation.
Well, the fact that I thought this whole project would take months to years, but we found 4 interesting objects in 3 days, that was, it was astounding and absurd in some ways, and a good absurd. I just never thought we would have been that successful, and people have been that eager to help find it. And these are just the top 4. We have another 300 objects we're still trying to go through the process of checking to see if they're known asteroids or known objects or not. And then there's the other data set, so we have more images to put out, which we know at this rate people will go through in 5 days as opposed to 3. Using the Kepler Space Telescope, we had people look through K2. So K2 is the current mission of Kepler, and they were looking for new planetary systems. And of course, one of these cool systems was a 4-planet system. So again, in 3 days, citizen scientists found a new solar system, a new stellar system, that has 4 planets around it. And these four planets are remarkably close. All four planets orbit the star closer than Mercury does to our sun.
So what is this, Darwinian system? What are we going to call it?
That's right. I like the Darwinian system. So there was a number of people that actually saw this. So we had, again, 30 people checking each system. And there was a number of Australians. There was also someone from UNSW who did it. But it's great that one of the main people who did this was a mechanic in Darwin. This just shows that when you make data in science accessible, everyone can do it.
Everyone loves science.
Exactly. It is for everyone. And everyone loves finding new stellar systems. So I hope that we choose a name fitting of all of the people who put in all their efforts to find these. And there's a bunch of other star systems that we didn't even talk about because, well, it's cool when you find a 4-planet system in a few days.
How long will it take to process all the information?
So that's a great question. So right now we're still trying to find these 4 unknown objects because there's a lot of uncertainty in their orbits from 3 points. There's all the other hundreds of objects we have to vet. So we have a lot of work to still do, but we're eager and I'm chomping away at it as fast as possible. So I hope that we'll at least figure out what one of these unknown objects are in the next few weeks.
You had more than 7,000 volunteers. They were classifying over 1.5 million points of interest as part of the project. It's obviously been a big job.
That's right. And then with the Planet 9 search, we had over 60,000 people. And each of those images that we had, which is 110,000, were checked by 50 different people. So we had at least 5 million eyes checking these things. And so over the course of this project, it was remarkable to turn out. And it was just perfect to show how great Australian astronomy and science is on both the national and international scale. And I love it.
The degree of popularity you've seen here, does this point the way where the people with a purse string should be looking?
Yeah.
What's interesting in the world, what people like?
I think, yeah. I mean, I think that the more interactive and the more engaging you make things to people, it shows that they can do it. If you put a little effort in and you get a lot of people who care about it, you can do great things. And that's the great thing about Stargazing Live. You're not just allowing people to do astronomy and learn about the facts. They're not watching the show. They're a part of the show. You're engaged with it. And the fact that the BBC had 16.1 million people tune in, which, it's almost like 1 in 3 people on the island almost. That is astounding to have that many people tuning in for a science program, if you think about it. Like, that's what they did. And so when you make it engaging and when you make it fun, I think that, you have a recipe for success and people want more of it.
That's Dr. Brad Tucker from the Australian National University. And this is Space Time. I'm Stuart Gary. If you want more Space Time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and junk on the web I find interesting, important or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter. And on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Physicists have discovered a new property exhibited by the Casimir effect, a strange force that impacts matter on the smallest of scales. The new research, reported in the journal Physical Review Letters, expands what scientists already understand about this strange quantum property by showing how it can affect the motions of nanoscale particles. To understand what's going on, we have to take another journey, dare I say trip, into the strange, spooky world of quantum physics. In theoretical nanophotonics and quantum theory, the Casimir effect is caused by quantum fluctuations due to virtual particle pairs which are constantly popping into and out of existence. A quantum fluctuation is a temporary change in the amount of energy at a point in space, as explained in Werner Heisenberg's uncertainty principle, allowing for the sudden creation of particle-antiparticle pairs of virtual particles. These virtual particles are the same as real particles, except that they suddenly seem to appear out of nothing and then disappear again just as quickly. There are 17 known elemental particles in the standard model of particle physics, the foundation of science's understanding of the universe. These are the basic subatomic building blocks that make up everything we know in the cosmos, from galaxies and stars right through to people and cars. They include quarks, neutrons, electrons, photons, muons, taus, gluons, W and Z bosons, and the now famous Higgs boson. Yet to be confirmed are the particles associated with gravity, the so-called graviton, which might not exist after all if gravity is just the effect mass has on the fabric of space-time, as Albert Einstein's theory of general relativity tells us. And it's worth remembering it's never good betting against Einstein. Scientists are also still trying to understand dark energy and dark matter. Although they can see the impact of these two dark forces on the space around them, they have no idea what they actually are. Quantum field theory tells us that the 17 elemental particles, in reality, are nothing more than excitations of underlying quantum fields. And the virtual particles are just as real as the real ones, the difference being they exhibit only temporary excitations of the underlying quantum fields. They're caused when an elemental particle, say a photon, splits into an electron and its antimatter counterpart, the positron. Now, according to quantum theory, every elemental particle spends some time as a combination of other particles in all possible ways. In other words, one particle will suddenly become a pair of virtual particles, which then quickly rejoin back into the original particle as if they had never existed in the first place. And the Casimir effect is one way to prove that these virtual particles are in fact real. Imagine a vacuum chamber. The Casimir effect describes a force generated when virtual particles are squeezed out as two light-impenetrable boundaries, such as say a mirror or metal plates, are slowly moved closer and closer together. Eventually, these light-impenetrable boundaries are so close to each other that they literally restrict the ability of some virtual particles to pop into the space between the boundaries. However, because there's no restriction on virtual particles popping into and out of existence beyond the light-impenetrable boundary, they continue to occur. All these virtual particles popping into existence outside the light-impenetrable boundary combine to generate a small but very real force, pushing the two light-impenetrable boundary plates together. That is the Casimir effect. Or to be more precise, the static Casimir effect. The effect's caused by the fluctuations of electromagnetic waves, and it can be measured. When studied using classical physics, the vacuum chamber wouldn't produce any force on the objects. However, when looked at using quantum field theory, the vacuum is filled with these virtual particles, creating a small but potentially significant force on objects. One of the new study's authors, Assistant Professor Alexandro Manjavakis from the University of New Mexico, says the findings have important ramifications in nanotechnologies, where distances and dimensions are so small that the Casimir effect dominates everything else. His research expands on the Casimir effect by developing an analytical expression for the lateral Casimir force, which is experienced by nanoparticles that are rotating near a flat surface. Imagine a tiny nanoparticle sphere spinning over a surface. Now, while the sphere will slow down due to photons colliding with it, that rotation also causes the sphere to move in a lateral direction. In our physical world, friction between the sphere and the surface would be needed in order to achieve that lateral movement. However, the nanoworld doesn't follow the same rules, thereby eliminating the need for contact between the sphere and the surface for movement to occur. Instead, the nanoparticle experiences a lateral force as if it were in contact with the surface, even though it's actually separated from it. The authors also found that the direction of the force can be controlled by changing the distance between the particles and the surface. It's a strange reaction, but one which may prove to have significant impact for engineers developing nanoscale particles at the very smallest level of the material world. While the static Casimir effect does all this in 3 dimensions of space, the dynamical Casimir effect does the same thing in the dimension of time. In fact, a few years ago on ABC Star Stuff, my predecessor program to SpaceTime, I reported on the work of Professor Tim Duty from the University of New South Wales. He used the spooky properties of the dynamical Casimir effect to force a mirror to create its own light out of empty space, rather than simply reflecting the light around it. Reporting in the journal Nature, Duty and colleagues were able to separate one half of each virtual particle pair before the particles could reconnect and pop out of existence again. The process forced the remaining virtual particle to become a real photon. To achieve the effect, the authors needed to accelerate a mirror to relativistic speeds, that is, close to the speed of light, some 300,000 kilometers per second in a vacuum. Of course, that's impossible to do in real life, so Duty and colleagues instead used a superconducting quantum interference device, or SQUID. The device acted as a tunable electronic mirror for virtual microwave particles, causing some to be scattered in the real world before they could pop out of existence again. By doing this, the mirror began radiating its own photons in the microwave band. The photons produced in this experiment had very specific quantum microwave correlations, with the waves at one frequency correlating to waves at another frequency, something which doesn't normally happen for classical microwaves. Understanding the properties of virtual particles will help scientists researching physics ranging from gravitational waves through to the evaporation of black holes through Hawking radiation. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and junk on the web I find interesting, important or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter. And on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.